Hello everyone, my name is Jeevan Mankar, and along with Tejo, I am working on the final project investigating key factors influencing life expectancy worldwide for data visualization. Life expectancy is the average number of years a person is expected to live based on statistical data and mortality rates within a specific population. It's a statistical measure and can vary significantly between different countries, regions, gender, and socio-economic groups. Factors influencing life expectancy include access to healthcare, quality of healthcare, lifestyle choices, environmental factors, and also advancements in the field of medicine and technology. There has been a lot of research which has been done around life expectancy and its influencing factors. So some of the existing visualizations we have is first is this Preston's curve, which shows that health and income are positively correlated across countries, and both life expectancy and income have increased between the years 1960 and 2015. Then we have this map-based visualization for life expectancy. This shows that the life expectancy varies across countries ranging from 50 to 86 years, and countries with the worst life expectancy is between 50 and 60 years. The population of the Central African Republic has lowest life expectancy in 2019 with 53 years. This is the time series visualization of life expectancy. This shows that there has been a dramatic increase in the life expectancy over the last few centuries. Overall, all the continents have shown tremendous increase in the life expectancy. And since 1950, there has been advancement in the field of science and technology, life expectancy has increased linearly. Then we have the bar graph of life expectancy for some countries. This shows that country Switzerland has the highest life expectancy with around 71%, and India with the lowest with 42%. There's also a line graph of life expectancy. This shows that countries like Japan, Spain, and Korea stand out, having relatively high life expectancy, and United States and Russia with low life expectancy given their levels of health spending. So through this project, our objective is to visualize and analyze life expectancy for various countries. Additionally, we aim to investigate the impact of various other factors such as vaccination rates, alcohol consumption, BMI, and GDP. These visualizations offers us valuable insights into the dynamics of life expectancy trends across nations over time. And life expectancy is often used as an indicator for overall health and well-being of the population. So it motivates policymakers and healthcare professionals make decisions about public health interventions, healthcare, and social policies. We took this data set from Kaggle, which is a life expectancy data set from WHO. We have 2939 observations for both developed and developing countries, ranging from the year 2000 to 2015. This is how our head of the data set looks like. We have columns containing country, year, status, developed and developing, life expectancy, vaccination rates, GDP, etc. So the visualizations which we were able to get, first is for distribution of life expectancy by country status. This shows that this is a box plot to compare distribution of life expectancy by country status for developed and developing countries. This is created using Seaborn library and use Matplotlib for visualization. In the box plot, this blue box represents the developing country status and orange box represents developed country status. This shows that the life expectancy for developed countries is around 80 years and for developing countries is around 70 years. Then we have the distribution of alcohol consumption by country status. This also shows that developed countries are having high alcohol consumption in comparison to the developing countries. In developing countries, it's around median of 2.5 liters per capita, while with developed countries is around 10 liters per capita. Outliers exist in both groups. There are few countries with high alcohol consumptions in both developed and developing countries, which are represented by the black dots above the upper whiskers of the box plots. Then we have a relationship between BMI and life expectancy. It is a correlation heat map that shows the relationship between BMI and life expectancy. The numbers in the cells represents the strength of the correlation. That means the value of 1 indicates a perfect correlation, while the meaning of -1 would be a negative correlation. And it shows that there's a slightly positive correlation between BMI and life expectancy with the value around 0.57. Then we have the trend of immunization coverage over time for different vaccines. It shows that the coverage for hepatitis B, polio, and diphtheria vaccines for both developed and developing countries. The developed countries have higher coverage for all three vaccines than developing countries. The coverage rate for hepatitis B vaccine for developed countries is highest around 95%, uh, while for developing countries it is around 84%. Overall, all countries, whether it's developed or developing, have shown tremendous growth improvement in the coverage, vaccine coverages over the years. So for next set of visualizations, I would like to invite Tejo to take it further. Thank you.
Thank you, Jeevan. So here we see the immunization coverage for countries with the GDP growth and as well as the GDP of greater than 50K, as well as the different various vaccinations. The blue line represents the developed countries and the orange line represents the developing countries. Over here we see we have taken a sample because the most of the results were filtered out, and we these are the hepatitis B, polio, and diphtheria vaccines. And overall for all these, we see the Kuwait has the highest vaccination rate or the immunization rate of around 95% for all. And this is the combined immunization coverage, so which we have used the chloropleth map for the combined immunization. So countries such as the Canada, Russia, and Brazil have highest immunization coverage for 80%. This is shown as it is a green, which is more beyond the on the high mark from the 0 to 100 range. And the lowest rate countries are with the United States and Australia that has a coverage below the 20%. So we have also analyzed the life expectancy and the infant deaths over the year using the scatter plots using the Seaborn library LM plot. So this function particularly useful for visualizing the relationship between two variables and the associated regression line that represents their linear relationship. As we see, there is the linear relationship. There is a decrease in the number of deaths, infant deaths over here from 2000 to 2015 in the duration, gradual duration. So this makes sure that the good immunization is required for the improved life expectancy or the reduced deaths. The correlation that we have seen that we are seeing now is the Seaborn with the joint plot, where there is a comprehensive visualization using the KDA plot as well. There are different levels of density that exist. The lighter center has the region of high density, whereas it fades out gradually. The blue surrounding represents the lower density regions. The color intensity helps us visualize the density levels. The lump or the peak in the plot, even the high joint density, where both log GDP and the life expectancy have high values and are positively correlated. So the next graph that we see here is the cumulative distribution of life expectancy based on the country status. So the graph in a particular probability point of point two, we see the developing country on the left has a lower probability rate when the same is compared with the developed country. So this means that the developed countries have higher proportion of people with longer life expectancies than the developing countries. And the next one we have is the life expectancy of country. So we have used the tree map using the Plotly library to create this visualization. So this is an interactive visualization where when we hover over the country values, we see get the details of the country name and the expected life expectancy value. So here it is arranged in the descending order with the Japan being the highest and the Sierra Leone being the lowest with 46.11. So to come to the conclusion, so we have used this visualization that allows us the reader to better understand and help was motivate to help us the deciding factors such as the life expectancy, providing the immunizations, and also the good to help decision makers on the health, and as well as the health organizations such as the WHO to provide an opportunity to review and seek the medical help such as vaccines, immunization, money, food, and other facilities to improve the life expectancy in the country all over the world. Thank you for giving us this opportunity.
Thank you.